Yo, what's up, guys? Welcome to another live learning session. This one's on PyTorch again. And in this one, this is part 4, we're actually going to be training the neural network. So part 1, we built the neural network. So actually, this whole tutorial thing that we're looking at actually has multiple things before building the neural network, but I went ahead and just built the neural network first because that's just how I roll. Anyway, we're going to learn how to train the neural network. So I'm going to rename this notebook. So basic NN prereqs. So what we're going to do here is we're going to go, and this is just going to be basic NN.IPYNB. Oh, okay, here we go. So we're going to get the stuff that we had before. And we're also going to import a transform. No, this is fine, actually. We're also going to go import some more stuff. We're going to do, oops. So we're actually just going to do device. Why is it yelling at me? Failed to load Python extension. It's a warning. Okay. We're just going to do device equals CPU because I don't have the GPU on this Mac. We're also going to have to get this neural network here. And we're also going to have to create the test. We're also going to have to get the test data and the training data and the data loaders. So, if you remember earlier, what I did was I split the entire data set into test, train, and validation, and we'll probably cover that in a later video. We'll just do how to do, we'll probably do that when we do k-fold validation or something. For now, I'm just going to get the test and the train data because apparently the MNIST data set splits that for you, so it's just easier. Training data equals fashion MNIST. Root equals, is this directory? Yeah. MNIST, is that what I called it in here? Yeah, I mean, that's what this is, yeah. Train equals true. So we get the train data. Don't need to download it, we already have it. But otherwise you would do download equals true, but we're not going to do that because we already have it. And we're going to do the transform to tensor. Oh, it's transforms to tensor. Yeah, there it is. And the test data is going to be the same thing, except test is going to equal true. And now we're going to get the data loaders, which we didn't cover earlier. But I'll talk very briefly about what data loaders are right now. You can go and look at them a little bit later. Basically, what a data loader does is, I'm looking this up as we speak. It just makes it easy for us to get the data set stuff through it just makes it easy to load the data set, basically. Okay, let's see, what does this say to do? Data loader. So train data loader, train data loader, is data loader, training data, batch size, mess up, equals 64. And then test data loader equals data loader, test data, batch size equals 64. Cool. And then that's it for this. And we're going to set our, Aha, yes, okay, it's not test equals true, it's train equals false. Derp. There we go. Now we're gonna set model equals neural network. And we're gonna set some hyperparameters that allow you to control the model optimization. Hyperparameter tuning is a big part of machine learning. This is like super common if you're a machine learning engineer, you guys kind of do this shit. So anyway, we're gonna set hyperparameters learning rate equals 1e negative 3. Batch size equals 64, which we just set earlier as well. And we're only gonna do 5 epochs. 5 epochs means we're gonna train 5 times basically. So in the optimization loop, we basically do 2 things. We do training, where we iterate over the data set to try to converge to the optimal parameters. We do testing or validation, where we check how the test data performs on the neural network that has been trained on the trained data. So what we're going to do here is we're going to implement an optimizer and a loss function. And what we're going to do here is we're going to create the loss function, which we're going to use as cross entropy. Loss fn equals cross entropy loss. Yeah, there we go. And the optimizer, there's a ton of optimizers. I talked about the Keras optimizers already. We'll drop that below. You can kind of understand how the optimizers work basically from that one, but that one is not about the PyTorch optimizers. PyTorch probably has a few different optimizers than Keras, which is TensorFlow, which is the competitor, the main competitor. I'm sure there are other ones. But anyway, we're going to do SGD, which is stochastic gradient descent, which is the most basic version. And I'll drop a little link on core concepts for natural language processing, which includes SGD, which is really not a core concept for just natural language processing. It's a core concept for machine learning. It just happens to be that tutorial explains that. Optimizer is equal to torch.optim.sgd model.parameters with LR equals learning rate. There we go. So the optimization happens in 3 steps in the training loop. We're going to call optimizer and we're going to call it 0 grad. So we set all the gradients to 0, which is the reset, or sometimes reset, because once again, we remember we did the autograd earlier. We talked about the autograd in the last video, and the gradients are kept in PyTorch as a DAG, and they are persisted. And then we're going to backpropagate with loss.backwards, which we talked about in the autograd video as well. And then we'll call the step function to adjust the parameters by the gradients collected after the backward pass. So now let's implement 2 loops. We're going to train a train loop to train the data and a test loop to test the data. So first we're going to do def train loop, and we're going to need a data loader, a model, the loss function, and an optimizer. So our first step is we're going to do size equals len data loader. Did I do data loads? Data loader. Data loader dot data set. That's the size of the whole data set and not the batch size of 64. So for batch x, y in data loader, let's enumerate data loader. So now we're enumerating the data loader into sets, batches of 64. So, you know, we did the batch size earlier as a set, but this one basically tells us which batch we're in. We're going to pred equals model x. So we're passing the forward loop into the model. Loss equals loss function predicted y. Remember, this is what we did last time to talk about the gradients as well, to learn about the loss function. This is basically this is predictions, loss functions, sorry, backprop. Loss. So we're setting everything, all the gradients to 0. We're going to call the loss. We're going to go backward. That's the backprop optimizer.step. And if batch 0, so if we're up to 100 batches, loss current equals loss dot item. Wow, this is batch times len x. So every 100 batches, we're going to print out what the loss is, basically. Current loss, loss, current size. What the heck is this? Oh, okay. Current 5D. So this is 5 digits. Oops, this needs to be in brackets. And size in 5D. So this gets us the current, I guess the batch, and the size, and oh, they do loss 770. So this is digits, the number of digits that we're going to see here. And then we're going to do that. I'm not entirely sure what this means, but we'll see it in a moment. And then we're going to do the test loop, which is going to also take the same things. Once again, batches equals data loader, and then test loss equals, test loss and correct equals 0. Oh, sorry, 0, 0. Oops, oh my gosh, my typing. Okay. And then with no gradient, because we don't need it. And remember this, I think this is memory preserve. Like this is good for your for not your memory specifically, but for like the memory of the computer. Because it takes up, because remember that gradients are stored as a DAG, so they're stored, so this takes up less less memory, basically. Now we're gonna append loss function pred y dot item, and then correct is we're gonna add to correct if the correct if pred dot argmax. So remember that the prediction is not is going to be like let me finish typing this and I'll talk about this. Actually, that's probably a better idea. Okay. So the prediction is going to be a set of predictions, and it's not going to be like, oh, like this is definitely this class, like, because that's not how neural networks work. So test loss is going to be divided by the number of batches, and then correct is going to be divided by the number of size. Oh, so this is telling you the percentage correct. Okay. So print test error. So this is the accuracy, which is going to tell us the correctness. Times correct. Huh? Oh, yeah, I forgot. I have to put an F there. They wanted to do it with 0, 1 float. Which I've never seen this before. This seems kind of strange. Am I typing that right? That's what it says. We're gonna see. And then the average loss. Probably need to. Aha! I see what I did wrong here. Okay. What do you mean? I closed it. I closed it right here. Oh, I'm supposed to close it right here. Ah, that's why he was mad at me. Okay. Test loss. And they want to go to 8D. They want to go to AF, sorry. And then we'll go to a new line. Cool, so that's the test loop. And we're going to run it for t in range epochs. And remember that we can change epochs to whatever number we like. Epoch print f epoch t plus 1 /n train loop. Oops. Train data loader model loss function optimizer. Okay, and then test loop. Test data loader model loss function optimizer. Okay, and then print done. So, yeah. So, what does this teach us, kids? Oh, okay. What this teaches us is that I can't read. It should be F. Oh, this is the number trained out of the total number of samples. There we go. Okay, so over time, let's see, over time, we got to epoch 1, 51, 59, 60, 62, 63.9. So that's basically we got some 63.9 accuracy percentage, and we can probably get better accuracy. I think in the next couple videos, what we're going to talk about is how do we do k-fold validation, and I might do a conceptual piece on that before the PyTorch piece. It might be the PyTorch piece and the conceptual piece. Either way, we can do k-fold validation. By conceptual, I mean we might also look at sklearn. And then we're going to take a look at, let's see what it looks like when we turn epochs to 10. Because traditionally, or normally, we like to do 10 epochs. Like when I did the neural network from scratch, we did 10 epochs. So let's look at what it looks like with 10 epochs. And then we'll also take a look at, we should plot these accuracies, to be honest. I'm going to plot this accuracy. We should plot it over time. So we should return. Let's return this and return. Oh. let's return this. Yeah, 100 times correct. Can we round this? I think actually we don't need to, so we'll just return this. Oh, it's better now because we actually, our model has consistently gotten better because we started from, so we actually have trained it for 15 epochs because we didn't initialize a new model. But we got to 75.3. Now what we want to do is, let's just run, oh man, okay, but we'll have to reset the model. Let's do new model equals neural network. So we'll do new model equals neural network, and we'll also do, put this, drag this up one. No. Okay, you know what? I'm gonna drag this down one. Here we go. And then we'll also do plot stuff equals. We'll do plot x equals plot y equals. Yeah, okay. So y is gonna be, this is gonna be accuracy, and this is gonna be epic. So what we're gonna do here is, we're gonna do def train loop, total loop, or optimize loop. We can make this better, but I'm just gonna leave it as is. So what we'll do here is we'll take a epic num relevant or related accuracy, epic list accuracy list. There we go. That's what we'll do. And then we're gonna import matplotlib. We're gonna run optimize loop on plot x, plot y, and then, oh, do I not have matplotlib installed? Okay. Let's dash u install matplotlib. No. So I didn't know I didn't have this installed. What a crazy time. Okay, well, we're gonna move this all the way down to the, no, we should move this all the way to the top. Okay. Anyway, so now what we're gonna do is we're gonna optimize the loops. Plot x, there we go. I didn't give it the new model. I gave it the regular model. Well, okay. Well, this is a conceptual thing. I just want you to see the plot. It doesn't. Well, if it, let's see what this looks like in a text editor. It's not getting much better over time. So what I'm actually going to do here is we're going to stop this. How do I stop this? Gosh, darn it. Okay. So we're gonna do for 25 epochs. So actually, you know what? We'll just do this. And we'll train it for 25 epochs. And yeah, my computer's actually not heating up. So this is actually pretty low. Accuracy 6.2. What is this trash? Okay. Oh no, is it just really bad? I don't know what's going on anymore. Okay, well, we'll let it train, and then we're gonna plot X and plot Y. Oh. So I'm looking up how to do a line plot in matplotlib, so I'm not being dumb. So, oh, we should probably actually, yeah. I mean, we can talk about how to import this better, but let's just take a look at the text editor. 6.2 6.2. Really? New model. What did I do to the old model? Did I do anything to the old model? This one says model.parameters. Okay. So this is also a waste of time. So so this is like those things you have to look out for. How do I stop this? Stop. Okay. So what I'm actually going to do is I'm going to pass in this optimizer correctly this time. Optimizer equals new model. There we go. Is this the best way to do this? Maybe not. But it will work this time, I think. There we go. Okay, here we go. Also, I don't know how it started at 6.2 accuracy last time. That's like legitimately like, that's just trash. How long is this one taking? 26 minutes. Okay. Hopefully we'll have this wrapped up before 30 minutes. One epic 10. We probably don't even need to be on epic 10, but I want to show you 25 so you can kind of see like how like the accuracy kind of like levels out over time. Because after a certain point, and we'll go over, once again, we'll go over this in the k-fold validation. We'll see something. We'll see like the validation stuff. Like it's just not. After a certain point, I might not get to it on 25, but after a certain point, you'll see it kind of start to do this with the accuracy. And that's called overfitting, which means that it gets too close to the text data. I mean, to the test, not to the test, to the training data. Yeah. Cool. So now what we're going to do is pyplot.plt. Is that right? matplotlib.pyplot.plt. Plot x, plot y. And then, actually, I think it's just matplotlib.plt. Is it plot? Not plt, it's plot, yes. Whoop. That looks wrong. Show. Huh? That's not right. Matplotlib has no attribute named pyplot. Is it just regular plot? What? Okay, I don't know why I did that. That was so weird. Oops. Oh my god, please tell me. What is plot x? Oh my god, did I not append them? Tell me. Oh my god, I didn't append them. How much time do we have? It's 29 minutes. Okay. Okay. Well, we'll cover this in the k-fold validation one, which will be up next. So I'm actually going to cut this one short. Okay, cool. Yeah, that's it. So make sure you subscribe. See you guys next time.